Proof and experimental establishment Graytown was established in December 1968. Up until 1952, all such firings were conducted at Fort Gellibrand, firing into Port Phillip Bay. Between 1952 and 1968, firing activities were conducted at Graytown. P&EE Graytown is responsible for the conduct of proof and experimental firings of ammunition and munitions for the Department of Defence and other departments, and in service surveillance of Army ammunitions. The following is a brief view of the unit's activities. The 20mm system is the new ammunition for the Royal Australian Air Force FA-18 aircraft and is also used by the Royal Australian Navy for the onboard ship air defence system. The M61 gun being prepared for firing is a 6-barrel machine gun capable of firing up to 6,000 rounds per minute. In this scene, showing 30mm barrel and mount modified for single-shot firing, the round is loaded onto a breech block and locked. The firing contact is then placed onto the rear of the bolt. Various proof requirements require that the fired round be recovered and after firing measurements taken. The catching box consists of 2 compartments, one filled with sawdust, and is used to retard the fired projectile for recovery later. The 30mm Deefer cannon has a rate of fire of 1,300 rounds per minute and is used on the Mirage aircraft, and in this case is mounted on a special mount designed to dampen vibration. The target is made of very light paper with a steel burster plate further down range to function the round. This proof is the 40mm shot breakup fired by anti-aircraft Bofors currently used by the Royal Australian Navy. The gun in action is the 40mm Bofors, firing both single shot and auto. Here we see the 66mm rocket motor proof and entails the loading of the rocket into a specially designed proof tube. Mounted on the 2-pounder carriage, the rocket is then fired at a 20mm steel plate, 200 metres downrange. The second target is 130mm of Class 1 armour plate at 60 degrees to horizontal, simulating the glacis plate of a tank. This function proof is to determine the degree of penetration. Lastly, fuse action with HES warhead to test graze action on an angled target in the vertical plane, then with heat against a ground target, testing graze action in the horizontal plane. The sloping target is to assess graze fuse function of the piezoelectric M412 fuse. The vertical target is used to assess aiming distance. This firing is the proof of the L17A4 fuses for the 76mm armoured car. A Saladin barrel is mounted on a 25-pounder carriage and sighted onto a target from the muzzle. This is to proof arming and functioning of the fuse at 23 metres. All firings done at P&EE Graytown are fired from undercover. Hence we see a mortar being loaded. The projectile is placed in a spring-loaded clamp, placed in the muzzle and released by pulling on the lanyard, causing the clamp to spring apart. The fuse is under assessment in this firing, and we see the round passing through the witness screen and detonating downrange. The second and third firings shows the Gray's action on the fuse firstly failing to operate and secondly functioning the projectile normally. To assess recoil energy, a service weapon is mounted on a pendulum mount. The forward and rearward motion is measured as a distance and later converted using appropriate tables to a recoil energy. This mount is also used for accuracy firings for heat and practice rounds. Here is the fuse proof for M2A2 ammunition and consists of firing flash-filled projectiles at a target to determine aiming distances. The second array is for the functioning of the delay element of the HE round. As part of Project Hamel, the British-built light gun fitted with strain gauges from EDE was fired at all charges including P1 and P2 pressures to obtain data for comparison against the Australian-built weapon. The proof mount seen here is a platform designed by EDE and manufactured by OFM and eliminates the need for a tank to fire 105mm tank ammunition. It consists of a Centurion tank turret ring and includes a Centurion tank mantle and breech block. This configuration is used for all items of 105mm tank ammunition proof and includes barrel proof. Here we see the proof mount being prepared for a vertical accuracy. Lastly, we see the 105mm tank barrel on the mobile 5.5-inch mount. This mount is used for 105mm canister trials. One of the main reasons the proof range is located at Graytown is the areas of softy loam soils vital for vertical recovery firings. In theory, if a gun is elevated to within 4 degrees of 90 degrees to the horizontal and fired, the projectile will be fired straight up into the air, reaching its vertex height and return to Earth base first. The spinning motion of the projectile acts as a gyroscope and keeps the nose fuse in a vertical position. When the round strikes the ground base first, it is a simple matter to dig down and recover the projectile and fuse undamaged. The fuse is then assessed for function and position of the various safety and arming mechanisms. The projectiles normally go down approximately 5 metres. The time of flight is about 90 seconds. These structures are now not in use for this type of proof due to their unsafe nature. Here is the static detonation of a 105mm HE round to assess the fragmentation pattern of the round after detonation. This test was conducted to assess fragmentation of the practice bomb when initiated. A small amount of HE explosives at the nose and tail of the bomb is used to mark the point of impact when dropped from an aircraft. Graytown was tasked to provide information on what the effects of a rocket-propelled grenade detonating claymore mines and stores on the top of a M113. From the explosion you can see satchels of unexploded claymores being propelled through the air. The resulting pressures within the vehicle were very high. Trials of the Baby Viper charged linear demolition were conducted in 1983 to assess the serviceability of existing war stocks of this item. In theory, the Viper consists of a rocket motor, a launch ramp, an explosive hose 185 metres long, and head and tail detonators. The Viper is launched over a minefield and blows a footpath 180 metres long for assaulting troops to use. The parachute seen here initiates the tail detonator and the setback force from the rocket initiates the head detonator. This trial consisted of an ISO container loaded with 9.2 tonnes of 30mm ammunition propellant, which was initiated by fire. The aim of the trial was twofold. A, categorise the propellant with respect to explosive potential, and B, give an estimation of time a road transport driver would have in which to evacuate the vehicle if, whilst transporting the bulk propellant, the vehicle crashed and burnt. 6,000 litres of kerosene was poured under the container and lit. This took approximately 3 minutes for the propellant to start to burn, highlighted by a change in flame colour. Surprisingly, when the propellant caught alight, it did not burn to detonation. As part of an ongoing project with EDE, the proof range is involved in the testing of the Australian production 105mm canister. Here we see the 105mm tank barrel mounted on the 5.5 inch being prepared and fired.